Okay, so one last way I want to talk about area between curves is, what if the functions don't work out so nicely for us if we look at them a certain way? So what do I mean by that? Let's say we have something like this where, we have two curves in the plane. Let's say one of them is, just pick something simple like this. And the second one, well, maybe it looks something like this, right? So here, here we're saying, we're talking a little more generically. We're not really saying the area between two functions, at least if we're thinking of them as functions of x. Because while this green one is a function of x, this blue one isn't, right? It fails the vertical line test. So, but I can still ask the question, what's the area in here? Right? How do we do this? Well, the way we can do this is say, this function is better described as x equals f of y. Right? And this function we can describe either way, but we may as well say it as x equals g of y. And if we look at things in this direction, then now we're, again, back to the area between two functions, right? With all the stuff we did before. Here we have, say, from C to D. So this area here is just the integral from C to D of, here, we want to think about how we're going to get positive values out of this. When we're moving in this direction, it's going to be right minus left will give us that positive value. So f of y minus g of y, dy. Right? So, I'll just emphasize again, this is right, left. And, if you think of this picture here, if we sort of tilt this so that the y-axis is horizontal and the positive x-axis points upward, right becomes top, left becomes bottom. So it makes sense that this should be right minus left. So as a quick example of this, let's find the area. I'm sorry, this f is bugging me. Find the area between, I want to use the phrase bounded by. X equals 3 minus y squared and x equals y plus 1. Right? So this one, we can draw this by hand. You could use Mathematica if you want. One thing to keep an eye out for is if you're going to use Mathematica, when you plot this, if you plot, 3 minus y squared and y plus 1, this is going to give you a graph like you graphed 3 minus x squared and x plus 1 in our normal kind of xy plane. So if you want to graph these equations as they are and get the picture we're kind of expecting to see here, you might want to look at using contour plot. Anyway, but let's do this quick sketch by hand. It's not too bad. Right, so here we're going to have something like 1, 2, 3. We need the negative one here. 2, 2. I think I want to space these out a little bit more. Oh, okay. Didn't intend to do that. 1, 2, 2. Okay. So again, this is x and y axes. So what do these look like? Well, x equals 3 minus y squared. When y is 0, x is 3. When y is 1, x is 2. And when y is 2, x is negative 1. And you'll find that the other side looks like this. So we get something like that. It turned around a little too soon, but that's fine. So this is x equals 3 minus y squared. And here, let's see, x equals y plus 1. So again, when y is 0, x is 1. When y is 1, x is 2. Right? So we're looking at this line right here. Let's see, this should be down 1 over. My scaling was a little off, but we're looking at this area right here. Right? So to compute this, oh, sorry, I meant to put the label on this and write that in green. So to compute this area, we just do left minus right, but we need to find these intersections here. So to find the intersections, just do what we've always done. Take these two, set them equal to each other. In this case, we're going to be solving for y values. So we have 3 minus y squared equals y plus 1. Let's move everything to one side, say the right side here. We get y squared plus y. This will be minus 2, which factors as y plus 2, y minus 1. And so we get our roots to be, oops, writing x is a habit, right? We get y equals 2, negative 2, and y equals 1. So the area will be the integral from minus 2 to 1 of the top, or the right side function, which is 3 minus y squared, minus the left side function, which is y plus 1 dy. So we're integrating from minus 2 to 1 the function, let's see here, y squared. Sorry, which way are we doing this? It should be the other way. So it should be 2 minus y squared dy. Right, now we just want to integrate that. So again, that computation's not super interesting. So I'll just pop that into Mathematica real quick. Integrate 2 minus y squared. Y goes from minus 2 to 1. And we get, oh, interestingly enough, a repeat answer from earlier, 9/2. In fact, I think this is just the y version of the integral we already did. Let's see. Indeed it is. Funny that. All right, and there we go. So I just wanted to say, add that quick note at the end, we can do the integral in sort of, horizontal directions as well as vertical directions. Right? So that's that for finding area between curves.